Hello friends, welcome to Susan and John MathTube. In this video, we are going to start learning how to solve differential equations. And of course, the aim of this video is to teach you how to solve a very simple type of differential equation that's called separation of variable type or variable separable type. Anyway, let's have a small introduction to equations. Okay. In your high school life, I'm sure that you have learned about equations. And whenever you solve a real life scenario or whenever you solve problems related to real life, you might end up with equations. For example, an equation like x minus 1 equal to 0. So basically, an equation will have an equal to symbol and an equation will have 1 or 2 or 3 or ... unknowns. And your job is to find the value or values of the unknown that will balance the equation. Okay, so you can see that x is equal to 1 is the only value which will balance this system. So we call x equal to 1 to be a solution. Okay, now look at this. You have to understand one more interpretation of the equation. If you look at y is equal to x minus 1, I am going to collect only this much and I am calling it y. And you can see that this is a function. And if you plot the function, our solution will be the point where the graph meets the x-axis. Okay, let's move ahead. I will show you different equations. Another equation, x square minus 3x plus 2 equal to 0. And you call it the quadratic equation. And you might have learned that a quadratic equation will have two roots. Of course, I know the answers. The solution to the equation is x equal to 1, x equal to 2. And don't forget, solution means the value or values which can balance the equation. So remember, in an equation, your job is to find the value of the unknown or values of the unknown. Anyway, in a quadratic equation, there are two answers or two solutions. Look, if I plug in x is equal to 1, you can see that the equation will get balanced. Look, 1 plus 2 is 3 and 3 minus 3 will be 0. Again, you can check it, 2 square minus 3 into 2 plus 2. Okay, 4 plus 2 is 6, 6 minus 6 equal to 0. See, only 1 and 2 can balance this equation. There will be no other value which can balance this equation. Another interpretation, if you consider the polynomial x square minus 3x plus 2 as a function, and if you plot the graph, then you will be able to understand that the graph will intersect the x-axis at 1 and 2. Or in other words, the solution of the equation are the points where the graph cuts the x-axis, because at the x-axis the y value will be 0. Okay, let's move ahead. You have seen linear equation, quadratic equation, maybe trigonometric equation. Now remember, trigonometric equations will have infinite solution. This equation will be balanced by 30 degree, 150 degree, 390 degree, etc., etc., etc. There will be infinite number of values. And you can make the graph, or you can make the graph of y equal to sin x and y equal to 1 by 2, and you can see that these two graphs will intersect at 30 degree, 150 degree, 390 degree, etc., etc. Or you can imagine the graph of sin x minus 1 by 2 equal to 0, or this part. Yeah, okay. Anyway, let's move ahead. Now comes our differential equation. Like the name suggests, differential equations are equations which has dy and dx. A simple differential equation is dy by dx equal to x square. Now remember, whenever we study about rate of change, For example, if you are talking about rate of change of velocity, you can introduce the quantity dy by dx. If you are talking about rate of change in profit with respect to time, you can introduce dp by dt. If you are talking about rate of change in temperature with respect to time, so you can imagine dt by dt. And another method where we, or another scenario where we get these equations are, sometimes in the derivation techniques, when you are dealing with a huge object, the method, you can imagine the proofs which you have learned in physics, like the Bernoulli's thing, Bernoulli's fluid flow, or maybe in thermodynamics, or maybe in other contexts. You might remember you are dealing with something huge, but you will focus on one small part which represents the whole structure, or you believe that the whole structure is made up of different particles like this, like the cell in human body. You know that the human body is made up of cells, right? So kind of like that scenario, and you will be calling this area as dA and the pressure applied as dP, and then you will use the concepts which you learn in your subject, and finally you might end up with something like this. Once more, let me tell you, a differential equation is something which contains dy and dx. Let's make it very simple. And if you see only dy by dx, we call this a first order differential equation. And if you see the presence of d square over dx square, you can call it a second order differential equation. Anyway, let's fast forward and go to what you call type 1 variable separable. Now look at this. I'll give you a simple differential equation. X into dy plus y into dx is equal to 0. And once more I am telling you, these differential equations arise because we are doing something, some sort of experiment. Maybe a heat experiment, maybe experiments related to temperature, volume, pressure, profit, loss, anything. Wherever there is rate of change, or wherever we are deriving something using the infinitesimal part of a body, this differential equation will arise. And my job in mathematics is to teach you how to escape or how to find a solution to the differential equation. Anyway, I am 100% sure that this type is variable separable. I'll tell you the reason. Look at this. A differential equation will be variable separable if by mathematical manipulation you can bring the functions in x along with dx and functions in y along with dy. And you should always remember dx and dy should be kept in the numerator. Once more I will tell you, a differential equation will be called variable separable provided by mathematical manipulation you are able to bring functions in x along with dx and functions in y along with dy. And with the fact dx and dy will be in the numerator. And once you reach this stage, to solve, to find the solution, all you have to do is you have to integrate. By the way, I forgot to explain one small thing. Remember, suppose you have a differential equation. Let's say dy by dx is equal to y. Okay, now by solution, what we mean is the value of y which will be in terms of x. So what will be the solution of this differential equation? A function or a value of y in terms of x which will balance this system, and I am 100% sure this system will be balanced by the exponential function. Look, dy by dx of the exponential function is e power x. See, e power x equal to e power x. So I can say y is equal to e power x is a solution. Now I'll tell you one more interesting fact about this solution. If you multiply this by 2, again it will satisfy. So look at this, dy by dx will be 2 into e power x. See? So generally speaking, the solution will be a constant multiplied by e power x. So I want you to point towards a few facts. Look at this. This is a first order differential equation, and this is the general solution of that equation. And you can notice that the general solution contains one arbitrary constant. So fact number 1, when you solve a first order differential equation, your general solution will contain one arbitrary constant. And now look at this. This is a solution. This is another solution. And I'll give you even another solution, minus 3 by 2 into e power x. Look, dy by dx will be minus 3 by 2 into e power x. Dy by dx and y are the same. And remember, these solutions are called particular solutions. And the solution with this arbitrary constant is called the general solution. Once more I'll explain. A first order equation will have the general solution with one arbitrary constant. Okay, now let's jump towards our equation. So once more let me remind you, the type I am going to teach you is called variable separable. So I want all of you to take a pen and a paper and start working out along with me. So we have a differential equation, x into dy plus y into dx equal to 0. So I told you, by mathematical manipulation, my aim is very simple. Is equal to minus y into dx. What should I do by mathematical manipulation? I have to bring functions in x along with dx. So that into dy is equal to minus 1 by x into dx. Achieved. Look at this. I brought dy along with 1 by y and dx along with minus 1 by x, and if you want to make it neat, you can write 1 by x into dx plus 1 by y into dy equal to 0. So this is clearly variable separable because I was able to bring functions in x along with dx and functions in y along with dy, with the fact dx and dy are kept in the numerator. Now the solution is very simple, integrate. Okay, what is integral 1 by x? Yeah, natural logarithm x, ln x. By the way, don't get worried, ln x means log x to the base e. And to be honest, writing log x gives a lot of confusion, because if you look at any international books, log x will stand for log x to the base 10 and ln x will stand for log x to the base e. So it is better that you use the notation ln x. Yeah, okay. So integral 1 by x dx plus integral 1 by y is ln y is equal to integral 0 is a constant. By the way, whenever you integrate, I know that there will be an arbitrary constant. It will be like plus c1 plus c2 etc. But you can understand all these constants became something like c. Wait a minute. It's just an arbitrary constant, right? So I feel I should use ln c. You can use c, you can use e power c, you can use 1 by c, no one cares. It's just an arbitrary constant. Now we can apply the properties of logarithm. What is log a plus log b? Log a into b, okay, is equal to ln c. Now what I'm going to do is, I'm going to use the inverse operator and I get the solution xy is equal to c. See? So this will be the general solution. If you want, you can write in the form y is equal to c by x. See? As I promised, the solution is a function in y or function of y in terms of x, or the value of y in terms of x, which will balance the equation. Okay, let's try one more problem. Okay, let's write the solve dy by dx equal to e power x plus 1 by y. I am 99% sure this is variable separable because I can see by simple mathematical manipulation. Look at this, by simple mathematical manipulation. By the way, when I say mathematical manipulation, you can imagine all sort of algebraic operations like cross multiplication, like taking things from left to right, right to left, etc, etc, etc. So look at this, y into dy is equal to e power x plus 1 into dx. That's it. It's clearly variable separable. Look, y is along with dy and function in x is along with dx. And once we reach this stage, we integrate. So the solution will be y to the power 2 by 2 is equal to e power x plus c. That's it. You can leave it in an implicit format. Now remember, this is a general solution, and see, the general solution has one arbitrary constant. Okay, so remember, the question comes in the format solve. So solve the differential equation root under 1 minus x square dy plus root under 1 minus y square dx is equal to 0. Okay, before we start, I know some of you might be weak in differentiation formulae. Okay, so look at this, integral 1 by root under 1 minus x square dx. The formula is sine inverse x plus c. So I want all of you to write the formula over here. Now look at this, if you are interested in the formulae, if you want the whole formulae list, you can just visit our website and you can see that I kept the integration formula here. I have to add more, but can you see in the formula list there is integration here, and you can just scroll down, scroll down, and you can see all the formulae listed over here. And the formula I just showed you, integral 1 by root under 1 minus x square is sine inverse x plus c. So please visit our website www.sjmathtube.com. Okay, so look at this. Is this variable separable? It will be variable separable provided by mathematical manipulation you can bring functions in y along with dy and functions in x along with dx, with the fact dx and dy will stay in the numerator. Okay, you can use any method you like, any mathematical manipulation you like, but I am going to use another method. Look at this. I can see that dy should not be with root under 1 minus x square because this is the function in x. And I also know that dx should not be with root under 1 minus y square. So what I am going to do next is, I am going to divide throughout by the unwanted quantities. So I know that this root under 1 minus x square is unwanted here, and same with root under 1 minus y square. So I am going to divide throughout by root under 1 minus x square into root under 1 minus y square. I'll repeat, you can use any method you are comfortable with. I love this method, that's why I'm following this. So this and this will get cancelled, this and this will get cancelled, and the right side will be 0. See, 1 by root under 1 minus y square dy plus 1 by root under 1 minus x square dx is equal to 0. Voila, variable separable. Now what should we do? Integrate. And integral 1 by root under 1 minus y square is sine inverse y, plus integral 1 by root under 1 minus x square is sine inverse x. And like I told you before, if you want, you call the integration constant to be c, or you can call it sine inverse c if it gives you any advantage. Of course, in class 11, I am sure that you learned a formula, sine inverse x plus sine inverse y. And what will be that value? That will be sine inverse x into root under 1 minus y square plus y into root under 1 minus x square. So the left side becomes sine inverse. I think I should have written x here and y here, doesn't make any difference. I am going to get x root under 1 minus y square plus y root under 1 minus x square is equal to sine inverse c. Now what should I do? I should take sine on both sides. What should I do? I should take sine on both sides, because you know that sine inverse will give us the identity function. So we are going to get the solution now. Our solution will be x into root under 1 minus y square plus y into root under 1 minus x square is equal to c. We will try one more question. So the question goes like this. Solve sec square x into tan y dx plus sec square y tan x dy equal to 0. Okay, so the first thing is you have to check whether you can make it variable separable. Okay, you can use any method you like, but this is the method I am going to follow. Look at this. I can see that tan y is an unwanted quantity because it doesn't match with dx. And similarly, I can see that tan x is not matching with our dy. So I am going to divide throughout by tan x into tan y. So if you want, you can write tan x into tan y. You can keep on writing tan x into tan y, and 0 divided by tan x into tan y. So we get what happens here. This and this tan y and tan y will get cancelled. So we get integral sec square x by tan x dx plus sec square y the whole divided by tan y dy is equal to 0. Okay, now time to integrate. I hope you remember your integration formulae from your basic level. So look at this, we have some standard integrals. If the derivative of the denominator is the numerator, for example, look at this question, tan x and the derivative of tan x is sec square x, then our integral value will be log x. Anyway, by log I mean natural logarithm ln f plus c. So once more I will repeat, if the derivative of the denominator is the numerator, then the integral value will be log denominator. And with this fact, I know that the first integral will be reduced into log, think about it, yeah, tan x, plus the integral of the second one will be log tan y. And of course, I told you, if you have any benefit, you can choose the arbitrary constants according to your benefit. Anyway, it will be beneficial for me if I say the constant is ln c. Now look at this, the left hand side is log a plus log b, and log a plus log b will be reduced into, yeah, log a into b, that is tan x tan y is equal to c. So that's it, my friends. This was a small video and the first video in variable separable. In the next video we will come with more problems. So till then, my friends, bye.